na in-upload ko din sa Google Classroom. Okay, then, start na tayo ng DC motor. Okay? Okay, nakikita na po ba ito?
Bakit siya din?
Alam po, alam mo, diniretso ko na sa ano.
Teka lang, may pasa ka.
Okay lang, ma'am.
Ano kayo ginagawa ng PowerPoint?
Ay, hindi ko nga ma'am nakita yung inyong PowerPoint na binigay na may DC motor pala kayo. Kaya ako nagawa ng akin, pero yung nakita ko naman po ay di ako nag-ano ng ano, opo, price ko po. Tignan ma'am yung circuit ko. Opo, nasa dulo po yung mga, yung sa armature, wala sa gitna. Yun. So, ano ba to? Record. Record ako. Okay, so start tayo ng DC mode. So a machine that converts mechanical power into DC electrical power is called a DC generator. And the same machine, when used to convert DC electrical power into mechanical power, it is known as DC motor. So that means, baliktad lang sila or magkabaliktad sila ng principle ni generator. Okay? So si generator is from mechanical to electrical. And si motor is from electrical to mechanical. But from the construction point of view, there is no difference between a DC generator and motor. So an electromechanical energy conversion device or electrical machine that converts this electrical energy or power into mechanical energy or power is called a DC motor. So, ang conversion nito is electromechanical. So, electrical to mechanical. So, yung ating input power or electrical power, that is from voltage times current. And the mechanical power or the output power is angular velocity times torque. Okay, electrical power natin, which is yung input, voltage times current, and the mechanical power natin, which is the output, is angular velocity times torque. Okay. Electric motors are used for driving industrial machines, for example, hammers, presses, drilling machines, lattice, rollers in paper and steel industry, blowers for furnaces, etc., and domestic appliances, say for example, refrigerators, fans, water pumps, toys, mixer, etc. And the block diagram of energy conversion when the electromechanical device works as a motor. Okay, so kayo naman nagkita na ng mga laruan na powered by battery. Yung napapaandar ng battery. So may mga motor po yun sa loob. Kaya yun naandar. Which converts electrical power to mechanical power. Okay, so from this block diagram, so you can see an electrical system here, which is nandun yung input natin, yung ating electrical power, which is current times voltage. Then we have here the electromechanical energy conversion device, which is yung motor. Ang kanyang output is mechanical power. which is equals to angular velocity times torque. Okay, so that is electrical mechanical system. So it has been seen that when current is supplied to the armature conductors placed in the magnetic field, torque develops and armature rotates. Okay, so may video tayo about dyan later. So simultaneously, the armature conductors cut across the magnetic field and an EMF is induced in these conductors. The direction of this induced EMF in the armature conductors is determined by Fleming's right-hand rule. And doon, uh, kay Fleming's right-hand rule, to get the direction, we have here different formulas. So, alam ko na kayo ay familiar sa formula nito kasi nandoon yan sa electromagnetism natin. Or dun sa topic natin ng about magnetism, yung pagkuha ng force. Okay? Force po ito na. So, to get the force, we have here PIL sine theta. B is your flux density, I is your current in ampere, and L is your length in meter. Flux density is in Tesla, so ito ay MKS. And your unit for force is Newton. Then in CGS, we have F is equals to PIL sine theta over 10, and that is in terms of dynes. Wherein your flux density is in Gauss, current is in ampere, length is in centimeter. Okay. Then in English, we have PIL sine theta over 11.3 times 10 raised to 6, which is in pound force, wherein your flux density is in dynes, is in current, or I is your current in ampere, and length is in feet or inches. Okay, so that is how you get force or the direction of the armature conductors. Next, we have the back or counter EMF. Okay, so di ba noong sa generator, we have EG or generated EMF. Ano? So, dito naman, meron tayong back or counter EMF, which is parehas lang sila ng formula. This is flux per pole. Flux per pole, P and Z over 68. Okay? So, when a DC motor rotates, an EMF is induced in the armature conductors. So, by Lenz's law, this induced EMF E opposes the supply voltage V, and it is called back EMF. And to get that back EMF, we have flux per pole, P and Z over 60A, wherein your EB is the back or counter EMF in volts. Flux per pole is your magnetic flux per pole in Weber. P is the number of poles, N is your speed in revolution per minute, Z is your number of conductors, A is your number of parallel paths. Then to get A, ganun pa rin, we have lap winding and wave winding. In lap winding, we have A is equals to P times M, where P is your number of poles and M is your degree of multiplicity. So for example, simplex, duplex, triplex, quadruplex, and so on. Simplex is 1, duplex is 2, triplex is 3, and quadruplex is 4. Then we have wave winding, which is A is equals to 2 times M. And again, M is your degree of multiplicity. So, to get EB, ganun pa rin ang formula, yung pagkuha ng EG natin. Kasi nga, from generator, naging motor na siya. So, babalik ta rin niya lahat ng principle ni generator. Pati yung circuit, babalik ta rin nilang, and that is already your motor. Okay? Medyo mayroon lang part na magbabago, yung subscript, but that's the same. Ano? So, pagka naman po, yung inyong flux per pole, is in terms of lines and Maxwell, just multiply 10 raised to negative 8 and that's your EB. Kagaya lang na isa, generator. Tinawag lang tong back EMF kasi nandun na siya sa may output part. Kumbaga, yung umiikot na part, yun na yung output part. Hindi na kagaya ng generator na yung rotating part ay nasa input, di ba? Okay, next we have the torque. We need to get the torque enabled for us. No. We need to get the force pala. Force muna, enable us to get the torque. Kaya po meron tayong force na mga formulas. So by the term torque is meant by turning or twisting moment of a force about an axis. It is measured by the product of force and radius at which the force acts. So let's consider a pulley of a radius r, meter, acted upon a circumferential force, or F in Newton, which causes it to rotate at N, which is in RPS. RPS po ito ha. Tanggalin natin yung mga sulat. So, we have here a pulley. Then, to get the torque, here in the pulley, you have to get the force exerted there and the radius. Radius is from the center of the pulley up to the edge. Okay, that is your R, which is in terms of meter. Then we have here the force. Okay, yung force, yung exerted force dyan, yun yung nagpapaikot. Kaya naikot yung pulley natin dahil yung force. So, that force is in terms of Newton. So, to get the torque, that is a product of force and radius, that is F times R, which is in terms of Newton meter. Kasi si force is in terms of Newton and radius is in meter. That's why the unit is Newton meter or NM. Okay. Again, your N or the speed of the rotation is in RPS. RPS, okay? Next is power. So, to get the power, we have P is equals to force times velocity. And that is in terms of watts. Kasi, di ba, si watts po ay Newton meter per second. Yan po ay equivalent ni watts. Di ba? Force times velocity is Newton meter per second. That's why it's also the power or also the unit for power. Si Newton meter per second. Next, we have the work done by this force in one revolution. So to get the work, we have force times distance. What is the distance? Sabi nga ay 1 revolution. That means it is the circumference of the pulley, which is equivalent to 2 pi r. So to get the work done, we have force times 2 pi r. Force is in terms of Newton and R is in terms of meter. And you will get joule. That is Newton meter. The equivalent din po ni Newton meter is joule. Okay. Then we have the power developed. So to get the power developed or PDEV, we have force times 2 pi r times n. We're in 2 pi n. Okay, so di ba pag power developed that is in terms of watt kasi nga power. Okay, so we're in F times R is equivalent to torque, right? Ito. And 2 pi n is equivalent to angular velocity. Okay. So that means to get the power developed or P dev, we have P times angular velocity. Okay, so power developed is T times angular velocity. So, sama po ako ng mga formulas na yun, ha? Pakidagdag sa mga index card ninyo na rin, ha? Kasi gagamitin natin yan pag tayo ay nag-problem solving. Problem set. That will be on, your problem set will be on Friday. Right? Face-to-face natin is on Friday. Tama? Okay. So, may problem set po tayo noon. And that is from chapter 1 to chapter 2, which is from the magnetism to motor. So, you have to review. So, mechanical power output. So, to get the mechanical power output, we have different formulas. Okay, so we have P is equals to 2 pi nt, wherein 2 pi n is the angular velocity, right? Kaya nga siya ay omega t, or angular velocity times torque, wherein your n, or the speed, is in terms of revolution per second, and your torque is in Newton meter. Then, we have here 2 pi nt over 60, wherein your speed is in RPM, or revolution per minute, and your torque is Newton meter. Bakit po may over 60? Because dapat po ang ating speed is in terms of RPS. So if your speed is in terms of RPM, you have to convert it in RPS. That's why meron dito 60. Diba? Parang kinonvert mo lang si meter to second. Si minute to second. Okay, so we have now in terms of horsepower naman. Okay? So we have 2 pi nt over 550, that is in horsepower. When your speed is in terms of RPS and your torque is pound-foot. Okay, you will use this if hinahanap is horsepower and your torque is in pound-foot and your speed is in revolution per second. If your speed naman is in RPM, or revolution per minute, and your torque is in pound-foot, then your horsepower formula will be 2 pi nt over 33,000. Okay, so narinig nyo na ba to? Yung HP, horsepower. Yung mga rating ng aircon. Naka-HP yun. That is horsepower. Okay, what's next? Okay, so dito naman tayo kay types of DC motors. So, parang kagaya lang siya ni generator, we have the series, shunt, long shunt, and short shunt DC motor. Okay, so dito muna tayo kay series motor. Series motor daw, the armature coils and the shunt coils are connected in series. Okay, so isipin nyo lang yung itsura ng ating DC generator. Ano ba itsura ni generator natin? Diba? May RA, may EG, may RSP, may load dito, or may VP, diba? So we have here RSE, we have RA, IA, ISA, IN. Then we have here EG. Baliktarin nyo lang yan. Then, we will get here the VT, or yung ating source voltage. Then we have the RSE, RA, and EB. So, pagka nasa motor na, hindi na siya generated voltage, siya ay back EMF na or back voltage or counter EMF or counter voltage. Okay? But then, yung ating, meron na konti nagkaiba, no? So, yung EG naging EB, and then yung VT natin, siya ay source voltage na or VS. Ano kasi nga yung source natin is, ano na siya, electrical, diba? To mechanical. So, ito yung magpapagana ng motor, ito yung iikot, yung armature. Okay? Okay, so, yung nagpo-flow na current dito kay VS or VT is IN. Ano ba yan? Hello? Okay na ba yung boses ko? Parang nagro-robot na ako eh. Ay, nako. Okay na po. Nagro-robot na ako kanina. Okay, so, yung nagpo-flow na current dito kay ating source voltage is IL or that is equivalent to IS. Ano, yung IL natin noon, i-generator, IS na siya dito. Pwede pa rin naman na IL. E di, kayo na yung bahala kung ano yung palatandaan ninyo. Okay? So, yung ating EB, that is back EMF or counter EMF. VS or yung VT natin noon, that is your supply voltage, source voltage or rated voltage. IA, ganun pa rin, armature current. RA, ganun pa rin, armature winding resistance. Then RSE, yun pa rin yun. Ano? Series field resistance. So, yung IL naman or yung IS natin, that is your input current, source current, supply current, or line current. Okay, so yun yung mga iba't ibang tawag or different terms for IL, which is yung IS natin dito kay generator, motor. Okay, so pagka naka-series, equal lahat na currents na nagpo-flow, di ba? That's why your IA equal to ISE equal to IS. Okay? Then to get your back EMF, so mag KVL, VS minus IA times RA plus RSE minus EB. Bakit po minus EB? Kasi po dun sa flow ng ating pag-ikot, yung pinakahuling na daanan is negative. That's why it's minus EB equal to 0. Then we will get EB is equals to VS minus IA times RA plus RS. Okay? So that is how you get the equation for a series DC motor. Okay? So again, yung electrical part natin is yun na yung input and yung armature natin or yung nagro-rotate na part is nasa output side na. Okay? That is for series DC motor. Next is yung shunt DC motor naman. Sabi, armature coils or RA and the shunt coils are connected in parallel. Okay? So, imagine nyo lang yung shunt generator natin, then balik na rin nyo. Okay? So, yung ating VT, nandito na sa harap, which is equivalent to VS or source voltage. Then, we have RSH here sa gitna. Then, we have RA kasama ng ating back EMF. So, they are in parallel. Si RSH at RA. Kasi nga, shunt DC motor tayo. Okay, so to get the equation for your current or source current, mag-KCL lang kayo kay node A, then you will get IS, which is entering the node. We have ISH leaving the node, and IA leaving the node also. That's why it's IS minus ISH minus IA equal to 0. to get the equation for source current, we have ISH plus IA. Okay? Then we have ISH. So, saan makukuha si ISH? Are, that is from Vs over RSH. Why? Because RSH and the source voltage are in parallel. That's why the voltage across RSH is equal to the voltage here, or the source voltage. So you can get your current or ISH using this. So we have Vs over RSH. Next, yun naman, back EMF equation. So you will get the equation in the outer loop. Outer loop, we have Vs minus IARA minus EB equal to 0. Then we will get EB is equals to Vs minus IARA. So that is your back EMF equation. So now that we have current and voltage for shunt DC motor, so you can get, let's say, power developed. So power developed is yan yung output power, and that is EBIA. Okay? Si EB dito manggagaling, si IA ay di kukuhanin nyo din. Ano, di ba? At let's say PO na lang, output power, kasi kung makikita nyo, di ba ito na yung output natin, output side natin. Ito na, oh. So your output power will be voltage times current. So yung voltage dito, which is EB, times yung IA. Okay? Or tinatawag din siya na armature power developed. Kasi di ba nandito yung armature natin sa last part. So, if the question is, find the armature power developed, that is PO. Okay, or output power, which is EB times I. Okay, next, we have the compound DC motor in long shunt and short shunt. Again, imagine nyo lang yung nung nag-generator pa tayo, then balik rin yung lahat. Okay? So, yung ating VT nasa harap na, and that is equivalent to Vs or source voltage. Then we have RSH, and sabi kay long shunt, series field are connected in series with the armature coils. That's why RSE and RA are in series. Connected sila in series. Then yung shunt field daw, connected across the series combination. That's why RSH is in parallel with RSE and RA. Okay? So, we have here RSH, RSE, RA, yung ating back EMF. We have IS, ISH, ISE, and IA. Okay, so from this circuit, you can see that IA and ISE are equal, right? Because they are in series. Okay. Next is to get ISH, ganun pa rin, Vs divided by RSH. Okay? Kasi wala namang ibang nandito sa harap, di ba? Na tawag dito, walang ibang resistances na nasa gitna nila. That's why Vs is equals to the voltage across RSH. So you can get ISH using Vs over RSH. Okay, next, to get the equation for IS, that is IS minus ISH minus IA equal to 0. Then you will get IS equals to IA plus ISH. Okay, KCL lang kayo kay node A. Then, we can get the back EMF equation using KVL. KVL tayo sa outer loop. So, we will have Vs minus IA times RA plus RSE minus EB equal to 0. Then you will get EB equal to Vs minus IA times RA plus RSE. So, yan na yung mga equation natin. That is our equation. Next is yung short shunt. So, the series field are connected in series with the supply voltage. That means, ito yung supply voltage natin, nandito yung RS. Because they are in series. And then yung shunt field coils daw natin, or simply RSH, and the armature coils are in parallel. So, ito si RSH, ito si RA, they are in parallel. Okay, so, di ba, binaliktad lang, galing kay short shunt generator, binaliktad natin, then yan na yung ating short shunt motor. Then, as you can see, yung IS natin, or source current, and ISE are equal. Okay, but to get ISH here, hindi na natin magagamit si Vs divided by RSH because they are not equal anymore. Yung voltage dito, the voltage across RSH is not equal to Vs anymore because we have here RSE. So you have to get the equivalent voltage in RSH. So, kagaya lang din ng short shunt natin, putulin ninyo. Then, we have your RSE and Vs and then RSH. Then, you will get the summation of this voltage or voltages here, and that will be your voltage across RSH. So, that is Vs plus Is RSE divided by RSH. That is how you get ISH. Okay, Vs plus ISE RSE over RSE. So this is equal to IS or source current. Then to get IS, that is equivalent to IA plus ISH. Then yung ating back EMF naman, we have Vs minus ISE RSE minus IA RA minus EB equal to 0. That is KVL against outer loop. Then we will get EB is equal to Vs minus IA RA minus ISE RSE, and your ISE is equivalent to IS. Okay, so that is for short shunt motor. Okay, so next is the armature torque of a motor. Okay, so to get the torque developed in the armature, we have Tdev is equal to flux per pole PZ over 2 pi A times I. Okay, so use this if N or the speed is not given. So flux per pole, then pole, number of conductors divided by 2 pi times parallel path times armature current. Okay, so ito yan. Then we have here the power developed or Pdev, which is 2 pi n Tdev divided by 60. So yung Tdev natin ay dito galing. Then we have the electrical power converted into mechanical power in the armature, which is given by Tdev is equal to EB IA. Okay, so EB IA. That is in terms of mass. Okay, so bago tayo mag-solve, may papapanood ako sa inyo na video. Okay? So, dito muna tayo kay power stages. So there are stages of energy transformation in a motor and also the various losses occurring in it shown in the power flow diagram. So we have the electrical part and we have the mechanical part. Okay, so first is yung motor input muna. So ano ba yung ini-input dito? Di ba electric? Or that is power, which is in terms of voltage and current. Okay, that is your input power. And we have here the copper losses. Ang copper losses ay nasa electrical part. Ano kaya nandito siya? That is PCU. Then we have the driving power in armature, which is EBIA. And then we have here the mechanical losses or SPL. Then we have the output. Output or motor output power. Okay, so to get PDEV, that is SPL plus PO. So alin ba si PDEV o si PDEV? That is SPL plus PO. To get PN, so si PN, that is PDEV plus PCU. And to get PN also we have PO plus SPL plus PCU. So lahat ng losses. And we will have PN is equals to PO plus PN. VT squared over RSH plus I squared RA. So, remind ko lang kayo na yung VT dito is VS. Okay? Parang ganun pa rin, di ba? We have the mechanical efficiency, which is P O over PDEV. Saan yun galing? Mechanical efficiency, so ito yung part na yun. We have PO over PDEV times 100%. Then to get the electrical efficiency, ito yung part na yun, which is PDEV divided by PN. And the overall efficiency is PO over PA. Okay? It's the power stages for motor or DC motor. Next, we have the maximum efficiency. So just like in the generator, here the maximum efficiency is variable loss equal to constant losses. And to start in maximum efficiency, mag-start kayo kay IA max. To get IA max, we have the square root of VS squared over RSH plus SPL divided by RA. Again, RA is based on what type of motor you have. Meaning, if there is a series resistance or a resistance in series with RA, you will add it here. Just add it, let's say RSC or and so on. If there is a series resistance with RA, say for example, long shunt auto. Diba ito si long shunt, RA tapos RSC. Then you will add RSC here because they are in series with RA or RSE is in series with RA. Okay? So after that, you will get IL max or in motor that is IS max. We're in that IA max plus ISH or field current. Then to get the percent max or maximum efficiency, we have the input power or maximum input power minus 2VL, wherein VL or CL is equals to VS squared over RSH plus SPL and divided by PA max times 100%. Okay, so to get PN max, that is Vs times Is max. Saan galing ito? Okay. So, very similar to basic. Okay. So, before we start solving these example problems, let me show you a bit about how motor or DC motor works.
If you look around your house, you will see many devices that have electric motors, such as kids' toys, table fans, toothbrushes, hair dryers, and this electric cutting knife. How does the electric motor work? You turn it on and somehow it starts rotating. Why is that? In this video, we'll cover the basics of electricity and magnets, and then put it all together to understand how it works. This video is sponsored by Brilliant. Let's start with something called a circuit. You have a battery, some wires, and a device that uses electricity such as a light bulb. Electricity flows through the circuit, but as soon as there's a break in the wire, the electricity stops flowing and the light bulb goes off. The path must be complete for the circuit to work. This is best done through the use of a switch. Electricity flowing down the wire. This is called conventional flow. If we take the battery out and flip it, then the current will flow the other way. The light bulb will still work in either case, but there are some devices that will work differently depending on which way the current flows. Okay, so that's the basics of a circuit. Now let's come over here. This is a magnet. It has a north pole and a south pole, and it likes to attract other metal objects like these paper clips.
Mas enjoy ang snack time pag may snack kakulitan with Royal. Pakatodo kayo para sa pamilya, mag-Centrum Advance.
May over 25 protect.
If you bring another magnet towards it, opposite poles attract, and the same poles repel. Magnets don't have to be in this shape. For example, some magnets might be more flat like this. You can think of this magnet as always on. It's always working. You can't really turn it off. That's why it's sometimes called a permanent magnet. It's made up of many smaller magnetic domains that are lined up in the same direction. But later, I'll show you a type of magnet where this is not always the case. Let's take one of our permanent magnets and drill a hole in the center and put it on something that will allow it to spin. Now bring another magnet towards it. Our spinning magnet will immediately line up until opposite poles are right next to each other. Switch out the side magnet. The same poles repel and opposite poles attract. If we keep switching out these side magnets, then our spinning magnet will just keep spinning. This concept of the spinning magnet is really important. We'll come back to it in a moment. Here's a metal bulb which is not a magnet. It's made up of magnetic domains, but they are pointing in random directions. Now let's take a wire, wrap it around several times, and then create a circuit. The current through the wires forces the magnetic domains to line up. That means we've just made a magnet, or more specifically, an electromagnet. It can do the same things that a permanent magnet can. It can pick up pieces of metal, and it has a north and a south pole which will attract or repel other magnets. But the electromagnet is special, in the sense that it can be turned on or off, just like a light bulb. You can't do that with a permanent magnet. Now watch what happens when we flip the battery. The electric current was flowing this way, but now it flows the other way. This will cause the poles on our magnet to switch places. North will become south, and south will become north. This is called reversing the polarity of an electromagnet. Instead of flipping the battery, an easier way to do this is to just switch the wires. You should be aware that the electromagnet will get very hot if it's on for a while. Just a caution in case this video inspires any science projects. Let's come back to our spinning magnet. This time we'll replace the spinning magnet with our electromagnet. As soon as we connect the wires, the magnet turns on and it lines up with the side magnet. Now, in reality, connecting these wires would prevent the bolt from spinning freely, but what's important here is the concept of the spinning electromagnet. Now let's switch the wires to reverse the poles on the electromagnet. The same poles repel and opposite poles attract. Now reverse the polarity again. Same poles repel, and opposite poles attract. If we keep switching the polarity, our electromagnet will just keep spinning. To make this stronger, let's bring in another permanent magnet on the side. Notice how this side has the south pole towards the center, and this side has the north pole towards the center. The side magnets work together to spin the one in the middle. This right here shows the very basics of an electric motor, but we need to make a few improvements. The two side magnets can be replaced with stronger curved magnets. And instead of a bolt with wires, we're going to use a metal loop. This is called the armature. Connect our wires and we have a circuit again. This time you can think of the electromagnet as flat like this with the south pole pointing up. Now the armature will spin until opposite poles are lined up. We keep it spinning by switching the wires just like we did before. But this is a lot of work to sit here and manually switch these wires. We need to add something to the armature called a commutator. It's a ring with gaps on the opposite sides. The commutator will spin along with the armature. Now we connect the circuit with two brushes on the side. These brushes will slide along as the commutator spins, and they are spring-loaded so that they always maintain contact. The current flows from the wire, through the brush, the commutator ring, the armature loop, and back through the other side. Now we have our electromagnet and the armature spins. As we come around this time, the brushes will switch contact to the other side of the commutator ring. Remember, there's two brushes, so it's happening on both sides. Before the switch, the current in the armature is flowing this way. After the brushes switch sides, current will flow the other way. This means the electromagnet switches polarity, which will cause the armature to keep spinning. The commutator ring does the same thing as switching the wires like we were doing before, but this time it does it all on its own. It will continue to spin as long as we're connected to a battery. Disconnect the battery, no more electromagnet, and the spinning stops. Now so far we've only used one loop on the armature. This will cause our motor to have an irregular speed, and in fact, we could get stuck in this position, with the brushes halfway between commutator segments. What we can do is split the commutator ring and then add another loop. So first, the brushes are in contact with these two commutator segments, which turns on this electromagnet, which causes it to start spinning. Once we get to here, the brushes switch contact to the next pair of commutator segments, which means this loop turns off and the next loop turns on. Now this electromagnet wants to spin. The brushes switch contact and the next loop turns on. This keeps happening as our motor spins. It's almost like the loops will take turns being an electromagnet. Some electric motors will add many loops to the armature. This ensures that there will be a continuous spinning motion on the motor. This spinning force on the armature is called torque. Stronger torque means a faster spin. There are some things we can do to improve the torque of the motor. Electromagnets are stronger when there are more wires. This is true when we wrap more wires around the metal bolt, and it's also true when each of our armature loops are made of many wires. The motor will have stronger electromagnet, which means it will spin faster. If you look at some pictures of real electric motors, you can see lots of wires wrapped around. And yes, this is the same reason. More wires wrapped around means stronger electromagnets. Another way to make this stronger is to use more electricity. Let's learn a few more terms here. The part that doesn't move is called the stator. In this case, it's the two permanent magnets inside. These fit inside the edges of the motor case. The armature in the middle is also called a rotor. Remember, this is the part that spins. The axle goes through the middle here and then sticks out the back of the motor. What I've shown you in this video is called a DC motor. If you have a device that moves and is powered by a battery, there's a good chance there's a DC motor in it. Other types of electric motors will work a little differently than what I've shown here. No matter the type of motor, most of them will produce some type of spinning motion. Once it's spinning, we can use this to make different devices move. In this case, a kid's toy. Or even a fan that cools a room. The spinning of the motor can be converted to other types of movement, such as the side-to-disc motion that we see in this fan. Or how about this electric cutting knife? Each blade is going back and forth. It all starts with the spinning of the motor to turn a gear, which then pushes these two pieces back and forth. So hopefully this video has made a few light bulbs go off in your brain. If you like learning new things, head on over to
the concept of a DC motor. Pinanood pa? Okay, so kung gusto niyo ulit yung panoorin, nasa Google Classroom yan. Ano? And, okay, so let's start solving problems. Okay. So I will solve 4 problems and the rest will be your assignment. Ano? Please try to solve 5 to 9. Ay. Okay, so now, this series motor develops 80 Newton meter of torque when the current is 40 ampere. The load increases so that the motor current rises to 50 ampere. The torque now is, okay, so lagay muna natin yung mga given. So meron daw tayong torque. Sabihin natin torque 1, 80 Newton meter. Then, ang current noon ay 40 ampere. Ano na daw yung torque nung ang current ay naging 50 ampere. Okay, so pagka mga ganyan yung problem, kukuha kayo ng relationship between the given parameters. So, saan kayo kukuha? Sa formula. So, saan bang formula merong torque at current? Diba meron tayong formula na T dev is equals to flux per pole Z over 2 pi A times IA, right? So, meron tayo ditong torque at merong current. So, from that, you can see they are in, ano ang kanilang relationship? Is it inverse or directly proportional? Torque is directly proportional to current. Diba? Ibig sabihin, paglaki ng current, paglaki ng torque. Pagliit ng current, pagliit ng torque. Okay? So, they are directly proportional. So, that means we can have our equation, which is T2 over T1 equals to I2 over I1, right? Okay, so let's substitute the given parameter. So, si T2 natin alone, T1 is 80 Newton meter, I2 is 50 ampere over 40 ampere. So, what will be our T2? Paki-input sa calculator niya kasi wala akong hawak na calculator. Nakikita ko. 100 Newton meter. Okay, so this is our final answer. Naintindihan? So, kunyari naman, yung flux ang hinahanap, ang flux na to. Edi they are directly proportional pa rin. So, directly proportional to flux. Okay, so, ganyan pa rin yung nangyayari. Next, we have here a 25 kilowatts, 250 volts DC shunt dynamo has an armature and field resistance of 0.6 and 100 ohm respectively, determining the total armature or current when working as a motor. taking 25 kilowatts. So, ilagay muna natin lahat ng naging. So, 25 kilowatts at 250 volts. So, diba? Sa generator tayo. Ang rating na ganyan ay PO at saka VT, tama? So, kung babalik na rin natin, that means sa motor, siya ay Pin at VS. Tama? Siya ay input power na at saka source voltage. Kasi binaliktad na eh. Kung ito yung nasa huli noon, yun, yung given na ganito, siya yung nasa harapan. That's why input at source voltage. So, ibig sabihin, Pin na is 25 kilowatts and your VS is 250 volts. Meron daw tayong RA and RSH 0.06 ohm and 100 ohm. Determine the total armature developed. When we say armature power developed, nasa ba si armature? Ba nasa output part? That means, anong nawawala? PO. Okay, so i-drawing muna natin yung circuit niya. Shunt dynamo, that means shunt motor. So, we have here VS, RSH, RA, EB. VS, RSH, and EB. So, we have here RA, we have here ISH, and IS. Okay, so PO, ano armature power developed? That means, nandito na yung sa last part na to. Ano yung PO natin? PO or PDEF is equals to EBIA. Okay? That is your PO. EB times IA. So, we have to get EB and IA. Pero bago ang lahat, IA muna ang kuhanin natin. Let's get IA first. So, pag nag-KCL tayo dito, that will be IS minus ISH minus IA equal to 0. That means your IA is equal to IS minus ISH. So, to get IS, ito si IS. So, the voltage across RSH is equals to VS because they are in parallel. So, that will be VS over RSH minus, this is ISH. Then, to get IS, ito si IS, diba? Ito. Meron tayo, we have a given of input power. So, that is in here. So, that will be Pin divided by PS. So, that is your IA. So, that will be 25,000 divided by 250 minus 250 divided by 100. What is your IA? $97.5. Paki-store ako kay A. Store kay A. So, 97.5 ampere. That is your IA. So, now that we have IA, we can now get EB. So, ano ang equation ni EB? That is, diba we have VS minus IA, RA, minus EB equal to 0. That is your KBL sa outer loop. So, we have EB is equals to VS minus IA, RA. We have here VS of 250 volts. IA natin, 97.5. RA is 0.06. So, what will be our EB. Ang ilalagay nyo dito yung nakastore kay A ha. Alpha A. To 44.1517 volts. Ganyan po ba? Ah, 0.50. So, eksakto yan. Wala yung putol. So, we can now get PO, which is EBIA. So, EBIA, that is 244.50 times 97.5 ng ating PO. $625 watts. Okay, so that is our final answer. So, naintindihan po ba yan? Wala kayong tanong? Wait lang ha. Okay, so next problem. A 440 shunt motor has an armature resistance of 0.8 ohm and the field resistance of 200 ohm. Determine the back EMF when given one output of 7.46 kilowatts at 85% efficiency. Okay, so i-drawing na natin ng isa. Short. Dito, shunt motor. Shunt motor, BS. BS, IS, ISH, RSH, RA, plus minus P. Okay. So, ang atin daw, atong given na to ay, kung noon, ang ginigiven is VT, ngayon ay VS na. So, VS natin is 440 volts. Armature resistance is 0.8 ohm, and we have a shunt field resistance of 200 volts, 200 amps ohm. Back EMF ang tinatanong. Meron tayong output power or PO na 7.46 kilowatts. And efficiency 85%. Okay. So, back EMF, kuhanin natin yung kanyang equation. Dito, we have VS minus outside the loop or outer loop, we have IARA minus EB equals 0. So, that will be EB is equals to VS minus IARA. So, we have VS, we have RA, we have to get IA. Si IA dito is KCL muna tayo kay node A. So, IS minus ISH minus IA equal to 0. That means your IA is, lipat na sa kabila, IS minus ISH. So, si IS, saan galing? Ito si IS. So, that will be P in over VS minus si ISH, that is voltage across RSH divided by RSH, that is VS. So, VS over RSH. Ngayon, may input power ba? Wala. So, we have to get saan po kukuhanin? Ay, din sa efficiency at saka sa output power. Efficiency is equals to PO over PIN, and that is 0.85 na lang ha ang gagawin ko. Equal to PO 7.46 kilowatts or times 10 raised to negative positive 3 over PIN. To get PIN, that is 7.46 times 10 raised to 3 over 0.85. Anong PIN? Ha? Wait lang. Ano? 8776.06 na lang. Watts. Ayan. So, ayan na si PIN. Thank you po. So, paki-store ako kay A. Store nyo kay A, then ilagay nyo din eh. So, A divided by, or alpha A divided by VS. A divided by 440 minus 440 divided by 200. What is IA? Again. 4 decimal places. 7.465. Ampere. So, yan ang IA natin. Ano? So, meron na tayong IA. Makukuha na natin si EP. So, that will be 440 minus itong IA. I-store nyo kay B. Store kay B. So, that will be alpha B times RA na 0.8. Anong ating EB? Or back EMF? Or 25 point. Thank you po. Ayan. So, ayan ang ating back EMF. So, ayan. Do you have any question about this problem. Okay, so last problem. We have a 250 volts 4-pole wave wound series motor has 782 conductors on its armature. It has armature and series field resistance of 0.75 ohm, and the motor takes a current of 40 ampere. Estimate its speed and gross torque developed if it has a flux per pole of 25 milliweber. Okay. So, ang mga given, meron 250 volts. So, that is the 4-pole wave wound series motor. Wave wound, that is wave, which is 2 times M. And conductors natin, 782. Then, armature and series field resistance, so RA plus RSE, which is 0.75 ohm. Takes a current. Okay, so yung motor daw, nagtitake ng current, that means, itong current na to ay ibinibigay. So, ibig sabihin siya yung source. That means IS, the source current, which is 40 ampere. Estimate its speed and gross torque. So, NN, gross torque developed, or TDEV. That is your unknown. If your flux per pole is 25 milliweber. Okay, so, paano ito kukuhanin? Do you have any idea? So, ito muna natin ang circuit. Series motor. So, VS, may RSE, RA, EB. So, RSE. So, meron tayong IS, ISE, IA. Okay, so, to get N, ano yung pwede natin gamitin na formula to get N? So, meron tayong formula na, let's say, PDEV is equals to flux per pole PNZ over, PN 2 pi NT. 2 pi NT. Mali. Iba pala to. Pang EB pala yan. To get PDEV, we have 2 pi and PDEV divided by 60. Okay, so may N yan. So, kailangan muna natin hanapin si PDEV, which is, formula? Flux per pole, PZ over 2 pi A times IA, tama? So, meron tayong flux per pole, may Z, by A. Pero wala tayong IA. So, kuhanin muna natin si IA. Si IA ay meron din pala, kasi ito ay series, so IS is equal to IA equal din kay IS. So, meron din tayo na rin. So, direct sub lang pala to. So, TDEV is equals to 25 milli, so times 10 raised to negative 3. Number of poles is 4. Ang Z is 782 divided by 2 times I times A. Anong A natin? May M ba? Wala. So, that is 1. So, this is 2 times 1 or 2. Then, ang kabuuan ito, i-multiply natin kay IA. Ano IA natin? 40. So, ano TDEV? For 8.9183 Newton. So, this is your gross torque developed. So, ano naman yung speed? Paano natin kukuhanin yung speed? Meron na tayong TDEV. Saan pala galing itong formula na to? Okay, so, ang formula na yan ay galing dito. Ay, 2 pi m TDEV divided by 60. So, that is PDEV. Okay, so saan natin makukuha si PDEV? Si PDEV din po ay yung EBIA. So, kung natin si EB, meron tayong IA, kukuha natin si PDEV. Okay, so, PDEV is also EBIA. Okay, so we have to get EB. So, ang EB natin dito ay VS minus IA times RA plus RS. So, we have 250 minus IA na 40 times 0.75. Anong ating EB? $220 volts. So that we have EB and IA na. So makukuha na natin si PDEV. So si PDEV ay EB times IA. So that is 220 times 40. Nauutal na naman ng person. So 2 pi, anong N? Unknown. Anong PDEV? Ito. Pakilagay na lang ako dito over 60. So, sabi ko nga, ayoko na shift solve. So, anong gagawin? Taas mo to doon. Itong 2 pi at saka yung TDEV, ibaba mo para ang N lang ang matira. What will be your N? Ano po? Parang ito. Sure ka, hindi 337.5959. Okay, ano ulit ako? Okay. Ayun. So, 337.5959 RPM. So, RPM tayo kapag ka naka-over 60. Kapag wala yan, that is RPS. So, RPM. So, ayan yung speed na hinahanap. Okay, do you have any questions? Ayan, yung the rest of the example problems, please try to solve it. 5, 7. Ano ba to? 5, 6, 7. 5, 6, 7, and 8. Okay? So, ayan. Paki-screenshot na ako para ano. Are, series motor. Shunt motor. Compound, long shunt and short shunt. Are. Are. One, two, three, four, five. Next. And last. So, do you have any question? Wala naman. Okay. Yes po.
Ma'am, may mga questions lang po. Hindi naman po related dyan about po dun sa inyo pong naka-upload po sa G-Classroom po.
Okay. Yun ba yung ano? Yung circuit na iba?
Ano po, hindi, yun pong ano po mga dapat pong inood doon sa lab experiment kasi wala ata po nakalagay na details kung yun po ay gagawin ng groupings or individual. Yun pong mga ganon.
Okay, so ayan. Paliwanag ko na din siya ngayon. So, yun nga po, yung inyo pong laboratory experiment, naka-upload na yon. Okay, so kayo po ay bubuo ng, ilan ba kayo? 50? 47. So, kayo 47, bubuo kayo ng 9 groups. 5 student each group. Okay? So, meron lang sosobra ng tig-isa. Parang dalawang mag-aanim. Dalawa ang anim, tapos 7 ang tigli-5. Okay? Wala pong maiiwan na student ha. Walang maiiwan. Tapos, isasend po sa akin lahat ng pangalan per group. Okay? Then, you can start your laboratory experiment number 1. Okay? So, ganito po. Yun po ay pwede nyo nang simulan anytime. Basta po, next week ay maipapasa ninyo. Kasi po, next week, yung ating time ng klase, lahat yun ay yung 2 araw, hindi ko na po kayo i-minute noon. Ibibigay ko na yung time na yun para kayo makapag-review para sa finals and para sa laboratory ninyo. Okay? Then, sa Friday po, we have problem set. You will bring your ballpen, calculator, and index card. Okay? But your index card is not allowed during midterm examination. Okay? Only for PSET this coming Friday. Okay. So, do you have any questions?
Ma'am, meron pa po.
Yes.
Yun daw pong sa lab experiment, if handwritten daw po siya or naka-PDF or docs document po.
Okay. So, ano siya? Hard copy. Ipapasa niyo sa akin. Sige. Dahil online tayo nun, di ba? Online tayo. So, ipasa niyo muna sa akin yung pinaka soft copy niya. Then, pag nag-face-to-face tayo, or maybe sa midterm week, ipapasa niyo sa akin yung hard copy. Okay, so soft copy muna, then yung hard copy papasa nyo sa akin pag nag-face-to-face na. Which is a midterm week yun.
Ma'am, meron ba po? Ano po
Yeah.
yun? Bali po, isa lang po ang ipapasa ng buong group po.
Yes po. Isa
Ah,
lang.
sige po. Tapos, ang sunod pa po ay kung naka-engineering lettering daw po ang ang lab report.
No, typewritten na lang para hindi na kayo mahirapan. Typewritten yung report doon, ha? So, pagalingan na lang ng English. Okay. So,
Meron pa po.
ano? Ay, may picture yun ha. Lalagyan nyo ng picture. Parang documentation na kayo ay nagawa talaga. Meron yung kasamang picture nyo habang ginagawa niyo yung laboratory experiment. Okay?
Ma'am, meron pa po. Siguro para last na.
Sure ka?
Apple, sure po. Ano po, Arman po ay question galing po sa BOD ng 6. Nagpapatanong daw po kung yun daw pong final answer ay naka 4 decimal places po.
Yes, 4 decimal places po.
Sige po, ma'am. Thank you po. Yun na yung naman po.
Sige.
Thank you po.
Thank you din. Siguro na-send na sa inyo yung yung problem set. Pinapractice niyo ng isolve yun. Sige, Mr. Johnson. Yes. School na po. Oo. Para magamit natin yung time natin. So, meron pa?
Meron pa po pala, ma'am.
Sabi mo last
Sa
night.
sa lab experiment po. Ano po siya? Sa long or sa short?
Sa long na lang.
Tapos kung may margins daw po at saka kung may required po kayong font at font style. Font at font size.
Yung font po, kung ano na lang yung font ng sinend ko sa inyo, nang in-upload ko. Hindi ko alam kung naka-Arial ba yun. Basta igayin nyo na lang sa font na nasa PDF.
Sige po. Ay, ang po, ang border po.
Ha?
Ang border po, margin.
Border. Magsesend ako ng lagyan nyo na ng border. Lang, 1 inch.
Pero po, ma'am, di ka po ay ang inyong pong sinend ay yung parang may template po. Gagamitin ka po yung template po yung may
Oo.
yung may 120 batch statue pa.
Oo, gagamitin yun. Ay, ang lalagyan nyo lang ng border ay yung pinaka front page. So, gagawa kayo ng front page. Di may border yon 111. Ang 1 inch ng 1 inch ang border. Then, isasend ko na lang sa inyo. Ako na ang gagawa para pare-parehas.
Sige po, ma'am. Thank
Yun
you
ang
po.
front page lang. Front page lang. Pwede na kayo mag-start ng ng pinaka-report kung gusto nyo na.
Ay, ma'am, last na talaga po. Saan po sesend yung sa groups na list po? Kahit sa GC na lang po.
Oo, kahit sa G. Kasi baka magkagaya-gaya kayo. Inano ko ba as assignment yung classwork? Naka-assignment naman to. Doon yun na lang i-attach sa aking in-upload sa Google Classroom. Di ba na-attach yun? So, yung 9 na leaders, i-attach nyo na lang. Kayo na ang mag-attach. Okay.
Thank you po.
Okay, thank you. Gawa muna ako ng front page. Bye. That's all for today. Thank you for listening. Have a nice day.
Thank you po.
Thank you po.
Thank you po.
Thank you. Bye-bye.
Thank you po.